questions. This video we shall discuss further pure mathematics 2, October-November 2024, paper 22. Let's take a look at the first question. Find the value of the given integrations over here, giving your answer in a logarithm form where the a and b are the integers to be determined. So for these questions, we can just apply the result from the formula booklet MM19. Integrate 6 to 7 x minus 5 square minus 1 dx. You can just integrate by using the result from the formula booklet. It will be a cos of x minus 5. And then just put 6 to 7. Then this one, it will be a cos of 2 minus the cos of 1. So if you just apply the natural log of the inverse of hyperbolic, also can find it from formula booklet, you will get this one as a ln 2 plus 3 minus the ln of 1. So ln 1 is a 0, so therefore your answer will be ln 2 sub 3. Done. This will be the answer for the question number 1. Okay, so now we move on to question number 2. As given here, and then show that at this point the dy dx is negative 1 over 6. So for this question, we need to do implicit differentiations. 4y squared differentiate, you get 8y dy dx. I think over here, before we differentiate, it's better that to make our job easier to differentiate, we just apply the law of logarithm to split the ln xy to become 4 ln x plus 4 ln y. That will be easier. Again, the 4 over here, every one of them have 4. You can actually divide the 4, make it become 1 over 4. That will be easier for us. Now you apply implicit differentiations. It will be 2y dy dx plus the 1 over x plus 1 over y dy dx. Equal to 0. Join all the dy dx together. Okay, make it like this. Then after that, we just substitute at this point 2.5. So you will get 1 plus 2 dy dx equals to the negative 1 over 2. So therefore your dy dx is negative 1 over 6 shown. That is how you get the answer for the question number 2a. Now we're moving on to the question number 2b. Find the d square y ds square at the same point, like just now. But this time is a second derivative. So for second derivative, we will copy this result to the part b. Okay, so we just copy this result. 2y plus 1 over y dy dx plus 1 over x equal to 0. We double confirm. Yes, it's correct. So now we differentiate from here in order to get the second derivative. Keep the left, differentiate the right. You will have d square y ds square. Plus keep the right, differentiate the left. You get 2 dy dx minus a 1 over y square dy dx minus the negative 1 over s square equal to 0. So we can simplify them before we substitute the value inside the differential equations. Over here, we will get this as the 2 minus a 1 over y square dy dx square equals to the 1 over s square. Now at this point, so you get 1 plus 2 d square y ds square plus the 2, 4 dy dx just now is a 1 over 6 square. This one is a 1 over 4. Okay, so we just need to simplify it. 3d square y dx square. This one is a negative 2 over 36, 1 over 18. Okay. So we just need to, sorry, this one is equal. Okay, so you just need to press the calculator. Okay, you get the answer as 11 over 108. Okay, so just press the calculator, then you will get 11 over 108. Okay, yes, correct. Okay, so this is the answer. Now we move on to the question number 3. For the t 0 to 1, find the exact length of the C. So we want to find the arc length of the curve C. So what you need to do is to differentiate the parametric equation first, dx dt. You get this one as e power 2t minus a t square. Then this one, your dy dt. Using product rule, keep the left, differentiate the right, plus keep the right, differentiate the left. Simplify it, you will get this one as 2e power t times t. Okay, so now the formula for finding the arc length is integrate from 0 to 1, square root of the dx dt square plus the dy dt square dt. So what you can do over here is just replace the derivative of the dx dt and the dy dt that we have found just now. Just put it here and here. Expand, simplify, and we just we shall able to see how to integrate them. So over here we have e power 4t minus the 2t square e power 2t plus the t power 4 plus the 4t square e power 2t dt. So we can see that these two can be cancelled off. It cannot cancel exactly, just minus them to combine them together. So if you combine them together, then you will get from the negative 2t square, it will become positive 2t square. Okay, so basically you just this part over here, you just change from turn negative to become positive after you add together with the dy dt square. So that means we can actually factorize them back to this form. Okay, but this time it will be a plus in between. So it will be e power 2t plus the t square square. Now the square and the square root can cancel off. It will remain as e power 2t plus t square. Now we just need to know how to integrate e power 2t and t square. Integrate. Replace them, replace the value inside, you get 1 over e power 2 plus the 1 over 3 minus the 1 over 2 plus 0. Simplify them by just leaving the answer in exact form. You will get this as a half e square minus 1 over 6. Just like that. Done. That will be the answer for the question number 3. So now we move on to question number 4. De Moivre theorem to show the relationships over here. So from here, you should know that we need to let cos theta plus I sin theta equal to C plus IS. Okay. Then in order to get power 6 or 6 theta, we need to expand them by the power 6. Okay, like this. Then my left hand side is I apply the De Moivre theorem. The left hand side I apply the De Moivre theorem. The right hand side, I apply the binomial expansion, get c power 6 plus the 6c power 5 is plus the 15 c power 4 is square plus the 20 c cube is cube plus the 15 c square is power 4 plus the 6c is power 5, and last one is is power 6. Okay, so this is how you do the binomial expansion. We will need to group them together, all the real part group together, all the imaginary part group together. So the real part, c power 6 minus a 15c power 4 s square, and plus the 15c square s power 4, and negative s power 6. This is all the real part add together. And all the imaginary part, I group them together. 6c power 5s minus the 20c cube s cube, and then plus the 6c s power 5. Okay, so by comparing the real part, I will have cos 6 theta equals to the c to the power 6 minus the 15 of c power 4 s square plus the 15c square s power 4 minus the s power 6. Okay, so this is what I have for the real part. And for the imaginary part, I will have sine 6 theta equal to the 6c power 5s minus the 20c cube s cube plus the 6cs power 5. And in order to get cotangent 6 theta is actually cos theta divided by sine theta. So just divide them, cotangent. It will be, your numerator is cos 6 theta, like this. And your denominator will be 6c power 5s minus a 20c cube s cube plus the 6c s to the power 5. Okay, so but the right hand side, we have gotten the left hand side. The right hand side, we need to have the answer of cotangent. So we know that cotangent is a cos divided by sine, cos divided by sine, c over s. So what you can do here is that for the numerator, you divide everyone by s power 6. For the denominator, you divide everyone by s power 6. Okay, you do the same thing for the both numerator and denominator. Then you will get c over s power 6 minus the 15 of c over s square plus the 15 of c over s. Oh, sorry, this one is a power 4. This is a square. Then this one is a minus with a 1. Divided by 6 c over s power 5 minus the 20 of c over s power 3 plus the 6c over s. Okay, so this is what we have. Now we know that the c over s is a cotangent theta. Okay, so just highlight that c over s is equal to cotangent theta. Okay, just mention this. Then you can write this one as a cotangent power 6 theta minus the 15 of cotangent power 4 theta plus the 15 of cotangent square theta minus 1 divided by the 6 of cotangent power 5 theta minus the 20 of cotangent power 3 theta minus a 6 cotangent theta. So therefore, shown. So this will be the answer for the question number 4A. A bit troublesome. We need to expand until power 6, but no choice. These are the questions. We just have to do it. So now moving forward, we go for the part B. Part B, now they want you to solve the equations over here. So over here, you need to know how to relate them to the part A. They mentioned hands. They mentioned hands. So what you can do is that you can see that this one is a power 6, 5, 4, 3, 2, 1, and x power 0, okay, or the constant. So, but you can refer to the answer here. You can see that the power here, all the power even is on top. All the power even is over here. And all the power, odd power is below. So what you need to do is to separate the odd and even. Okay, so we separate, we just make x power 6 minus the 15x power 4 plus the 15x square minus a 1, and then let it equals to the 6x power 5, and then minus a 20x cubed plus the 6x, and we divide them like this. Divide the whole thing of the left hand side, right hand side, make all the right hand side divide to the left hand side, then you get a 1 here. This one will be 6x power 5 minus a 20x cubed plus the 6x. So we just need to let our x equal to cotangent theta. Then you will get cotangent power 6 theta minus a 15 of cotangent power 4 theta plus the 15 of cotangent square theta minus 1 divided by 6 cotangent power 5 theta minus a 20 cotangent cube theta plus 6 cotangent theta. You will have something like that. And refer to the answer A, you know the whole thing here is equal to the cotangent 6 theta equal to 1. So cotangent 6 theta equal to 1, it means that cotangent 6 theta is equal to the cotangent of pi over 4. Referring to the general formula, 6 theta is equals to the n pi plus the pi over 4, where the n starts from 0, 1, 2, and so on. Okay, we are looking for theta. We're looking for x. So power 6, we're supposed to have 6 answer. So that means we can just write our answer 6 is theta is equal to the pi over 4. This is the case where the n equal to 0. When the n is equal to 1, when the n equal to 1, you will get 5 pi over 4. When the n is equal to 2, you get 9 pi over 4. N equal to 3, you get 13 pi over 4. N equal to 4, you get 17 pi over 4. Now we have 5 answer already. We're supposed to have 6 answer. And the last answer that we want, it will be 21 pi over 4. Okay. So this will be the 6th answer. And then the theta divide by 6. Everyone divided by 6. 9 pi over 4, I don't plan to simplify it. I write it as a 9 pi over 24. Okay. So that we can see the pattern. Same thing here, 21 pi over 24. I don't plan to simplify it. I remain my denominator as 24. So therefore, my x is equal to the cotangent theta, cotangent 6 of them, cotangent pi over 4, pi over 24, cotangent 5 pi over 24, cotangent 9 pi over 24, cotangent 13 pi over 24, cotangent 17 pi over 24, and the last one, cotangent 21 pi over 24. Done. That will be the answer. Okay, this will be the answer for the question B. Okay, So now we move on to the question number 5. I find the particular solutions of the differential equations 3d square y dx square plus 2 dy dx plus y equal to s square. And given that when x equal to 0, y equal to dy dx equal to 0. Okay, so what you need to do is, first of all, second order differential equation, we need to solve it. We need to find the auxiliary equation first. We make it become 3m squared plus 2m plus 1 equal to 0. Factorize it. You get the m is equal to negative 1 over 3, and the m is equals to, I make a mistake. This one cannot factorize. Sorry, this one cannot factorize. This one, we need to solve it by using the quadratic formula. It will be negative b plus minus of the b square minus a 4ac divided by 2a. So it will be negative 1, 2a. 2a, a is a 3, so it will be a 6. So it will be negative 2 plus minus of 2 sub 2i divided by 6. So your m will be negative 1 over 3 plus minus sub 2 over 3i. So therefore, your complementary function, it will be the yc is equal to the e to the power of negative x over 3 a cos 2 over 3x plus b sine 2 over 3x. Okay, that is my complementary function. Now we want to go for particular integrals, bi. So the bi will be the yp. We need to check the relationship here, equations over here. This one is x squared, quadratic. So quadratic, we just put ax squared plus bx plus c. So I need to find y prime, 2ax plus b, and y double prime. It will be a 2a. Replace this inside the original equation. It will be 3 of y double prime plus the 2y prime, then plus a yp. And it will equal to s squared. So if you replace it inside, you get a 2a here. This one you will get the 2ax plus b. This one you will get ax squared plus bx plus c equal to 0. Rearrange everything, not equal to 0, equal to x squared. Rearrange everything, you get ax squared plus the 4a plus the bx plus the 6a plus the 2b plus the c equal to x squared. Now by comparison, the coefficient. By comparison, you have the a is a 1, the 4a plus b is a 0. That means your b is a negative 4a. Okay, and then your 6a plus 2b plus c is a 0. Then your c is a negative 6a minus the 2b. Then your c is a 2. Okay, so therefore, your general solution is y equal to yc plus yp. That will be e power negative x over 3, sorry, a cos 2 over 3x plus the b sine 2 over 3x plus the yp. It will be ax squared plus bx plus c. That will be my general solution. But the question are looking for particular solutions. So for particular solutions, I need to find the dy dx over here. So the dy dx on this one a bit troublesome. Keep the left. So I have to differentiate it carefully. Keep the left, differentiate the right. You will get negative 2 over 3a sine 2 over 3x. This one, it will be plus 2 over 3b cos 2 over 3x. Keep the left, differentiate the right. And then after that, plus keep the right, differentiate the left. Differentiate the left, you will get negative 1 over 3. And my right-hand side, just copy down. A cos 2 over 3x plus the b sine 2 over 3x. Then the quadratic over here, if you differentiate, you get 2x minus 4. Okay. Okay, so this is what we have. I don't plan to simplify it anymore. I just need to replace the value given when x is a 0, y equal to 0. So we're just using these equations. Let all the x equal to 0 and y equal to 0. So you get a 0 equals to the 1 of a plus 0 plus 2. Therefore, you found that your a is a negative 2. Okay. Then also given that when x equal to 0, my dy dx is also 0. So now this time I will be using these equations. So change the dy dx equal to 0, and this one is a e power 0. This one is a 0 plus 2 over 3b, and then plus the negative 1 over 3. This one is a negative 1 over 3. This one is the a plus a 0 and minus a 4. We have found that the a is a negative 2. So this one is a 2 over 3b. So this one is a plus 2 over 3 minus a 4. Therefore, this one will give you the b is equals to the 10 over 3. That means 3 over 2 multiply 10 over 3. So you get 10 2. 10 2, we can actually make it become rationalize the denominator. So it will become 5 2. My b will be 5 2. So therefore, your particular solution, so now you have found a and b. So your particular solution will be e power negative x over 2 over 3. A cos 2 over 3x plus b sine 2 over 3x. Okay, and then plus the quadratic. Just now is x squared minus 4x plus 2. Okay, so that's all. That will be the answer for the question number 5. Question number 5. So this is the answer. Okay, so now we will be moving on to the question number 6. Have a graph over here. The diagram shows a curve with the equations of y equal to e power 1 minus x for the x between 0 to 1 together with a set of n rectangles of the width 1 over n. And then by considering the area of rectangle, show that the area integrate the area here, the exact area, the actual area here is actually less than the un, where the un is given as such. So we need to know how to build the area of rectangle. So what I need to do is that at first I will call this one fx. I will call the curve fx. Okay, so your actual area is the integrations of e to the power of 1 minus x dx. If you want to be less than, that means the rectangle that you take must be higher than the area. Okay, the rectangle that you take must be higher than the area, the height. So it will start from f0, 1 over n, plus f1 over n over 1 over n. Continue with this pattern until the last one will be f n minus 1 over n multiply 1 over n. So you can factorize all the n out. This one you can write it as r over n. R start from 0 until n minus 1. You can write like this. But we already defined that fx look like this. So this will be e to the power of 1 minus r over n. Okay, so we can make it easier as well. We can take the e out, factorize it out. Then this will become e power negative 1 over n power r. You can get something like that. Now, this is a GP where the first term is e power. The first term is a 1. And then the common ratio will be e power negative 1 over n. So this is the GP. So if you use the formula, GP formula, it will be a of, okay, need to put the bracket carefully. It will be a 1 minus the r power n, okay, divided by the 1 minus r. Okay, so you just need to expand. You get this one as a e multiply 1 minus the e power negative 1 divided by n 1 minus e power negative 1 over n. Multiply the e inside, you get this. Shown. That will be the answer for the question number 5, part A. Okay, this is the question number 5, part A. So now we move on. Question number 5, part B. Number 6, sorry, not number 5, number 6. Number 6, part B. So use a similar method. That means refer to the method in A. We want to find the lower bound of these integrations. So what you need to do now is, if you want to be a lower bound, that means you need to choose the rectangle, height of the rectangle like this. Okay, you need to choose the height of the rectangle like this, no longer using this height. Okay, so that means integrate this. Since this is the lower bound, then your actual area will be higher than f1 over n multiply 1 over n plus f2 over n multiply 1 over n. Continue until fn over n multiplied by 1 over n. So very similar. You just need to factorize it out. This one will become r over n. Your r start from 1 until n. It will be the same as 1 over n e to the power of 1 minus r over n. Okay, exactly, the method is almost the same as I just now. Factorize the e out. Okay, factorize the e out. So you will end up with e to the power of negative 1 over n power r. So this is a GP as well. This time the a is e power negative 1 over n, and the r is also e power negative 1 over n. Sum of the formula, e over n, the sum of the n terms, it will be a 1 minus the r power n divided by 1 minus r. Okay, so what you need to do now is, we can go fast a little bit. Basically, the idea is the same. It will be e minus 1 and n 1 minus e power negative 1 over n. Okay, you will get something like this. Okay, so this is the answer. This is the answer for the question number B, 6B. Okay, I just leave the answer like this. But however, if you refer to the mark scheme, the mark scheme, actually they just make it like this. Okay, so how do you get from here to here is actually you just need to multiply both of them by e power positive 1 over n, multiply by e to the power of positive 1 over n, then you can get the answer same as the mark scheme. I do not think I need to do like that because the question didn't state any particular form I need to express it. So I will remain as this form because it's more convenient for me to do the following part, part C. So now I want to do part C. Part C is the limit of the n go to the infinity of the un and ln. Your un, this is the un, e minus 1. This is the ln. ln is e power negative to the ln. So you can see now the reason I want to remain this as an answer is because I want to make the denominator same. So the denominator same, that means it's easier for me. We can actually factorize the common factor out. It will be e minus 1, factorize it out. It will be e power this divided by this. And you can see that this can be cancelled off. So at the end, your expression over here will be limit of n go to infinity of e minus 1 over n. When the n go to infinity, you will get a 0 shown. Okay, so this will be the answer for the number 6C. And moving on. Oh, we still have one more part. Moving on, we have the Maclaurin series for e power x, given that in the list of the, use the Maclaurin series for e power x in the formula booklet FF19. And in order to find the first three terms of the series in ascending order of power of 1 over z, and deduce the value of un goes to infinity. So for this question, so we just look for the formula booklet, MF19. This is the Maclaurin series for the exponent e power x. Okay, we only want the first three terms. Okay, but over here I need to put 4 more terms. Okay, because I have 1 minus over here, so I need to make it 4 terms. Okay, so now if this is a negative 1 over z, that means negative 1 over z, it will give you 1 minus 1 over z plus the 1 over 2z squared minus the 1 over 6z cubed plus a dot, dot, dot. Okay, this is what I have. Then the series that they want you to find, it will be the same as a z, 1 minus this. So if you cancel it, then you will get this one as a 1 over z minus a 1 over 2z squared plus the 1 over 6z cubed. Multiply them inside, you get 1 minus a 1 over 2z plus the 1 over 6z squared. Okay, and so on. So these are the first 3 terms for the expressions here in the power of, in ascending power of 1 over z. Deduce the limit. Okay, so the limit of un, un is just now the un, okay, just now the un was e power e minus 1. Okay, so you can see that your n, z and z here, n and n here. So actually, we just need to change our z become n. Just need to change the z become n. So if you change the z become n, then it will be the same as the limit of n go to infinity of e minus 1 over the 1 minus a 1 over 2z, 1 over 2n. I changed the z become n already. Plus the 1 over 6n squared, and so on and so on. So now when the n go to infinity, you get e minus 1 over 1, then therefore you get e minus 1. That's all. So this will be the answer for the question number 6D. And moving on, we have question number 7. Show that differentiate ln tangent x, it will be equal to the 2 cosec of 2x. So for these questions, we just need to follow the formulas only. Ln tangent x differentiate is to copy down whatever inside the ln, and then you differentiate the tangent, you get sec square x, and then just put on top. And we know that sec square is actually 1 over cos. Then tangent is actually sine. This one is cos over sine. So you cancel it, you get 1 over cos x sine x. Then you multiply 2 for both. And you get this one as a 2 over the sine of 2x. Then you get this one as a 2 cosec of 2x shown. Okay, so this is the answer for the question number 7A. Now moving on, question 7B. They asking you to solve the differential equations. First order differential equation, given that when x equal to ln 2, your y is equal to 5, giving your answer in the exact form. So for this question, first of all, I need to divide everyone by 2 sine. Divide everyone by 2 sine 2x. Okay. Sorry, divide everyone by sine 2x. Okay, so divide everyone by sine 2x. Okay. Then over here, our IF is equals to the e to the power of integrate 2 sine 2x. But 2 over sine 2x is actually 2 cosec. And from part A, we know that differentiate ln tangent can give you 2 cosec x. So that means integrate 2 cosec x will giving you e power ln tangent x. E power ln tangent x, it will be same as a tangent x. Okay, tangent x. Now I multiply everyone by this is equation 1. I multiply everyone by the IF. So I get tangent x plus the 2 tangent x dy dx plus the 2 tangent x over the sine 2x y is equals to tangent x. So this one, the left hand side, it just take the IF multiply by the y, then the right hand side is you integrate the tangent x. Integrate the tangent x is not difficult. You're supposed to get ln cos plus a c. Okay. Now when x equal to the ln 2, so y is equals to a 5. That will give you tangent ln 2 multiplied by 5 is equals to the ln cos of ln 2 plus c. So we need to calculate by using calculator. Cos ln 2, using calculator, you get 5 over 4. Tangent ln 2, using calculator, it will give you 3 over 5. So we just put a remark here. So this one, you will get 5 over 4 times 5 is equals to the ln 3 over 5. Plus c. Sorry, I make a mistake. This one is 3 over 5. This one is a 3 over 5. This one is a 5 over 4. So you get the C as a 3 minus a ln 5 over 4. Okay, that is a C. So therefore, the answer here will be tanh x y is equal to the ln cos x plus 3 minus a ln 5 over 4. You can leave the answer like this. There's no specific requirement from the questions, but usually if can, we will make it as a y in terms of x. So if you want to make it become y in terms of x, then it will be like this. This will be the answer for the question number 7. Okay, so now we move on. Question number 8. The matrix A is given as such. Show that the characteristic equations of A is given as this expression. And after that, find the eigenvalues of A. So what you need to do is that to find the to form the characteristic equations, we need to find the determinant of the A minus a lambda. Okay, so this one, it will be -2 minus lambda. This one will be 7 minus lambda. This one will be 7 minus lambda. And the rest, just copy down. 0, 0, 0, 9, 4, and then 1. The determinant will be a 0. So just do the calculation only. Over here, you will get lambda minus 7 square minus the 9. The rest are 0. So we need to expand and simplify. So this one, it will be lambda square minus the 14 lambda plus a 49. Okay, this is what we have. Then you expand further, you will get the negative can cancel it because it's equal to 0. So you will have lambda cube minus the 14 lambda square plus the 40 lambda plus the 2 lambda square minus the 28 lambda plus the 80 equal to 0. So you get lambda cube and minus the 12 lambda square plus the 12 lambda plus the 80 equal to 0 shown. And after that, from here, we factorize it in order to find the eigenvalue. So we can just, from here, you factorize it. This part, the quadratic, if you factorize it, it will be minus 10 minus 4 equal to 0. So your lambda is a -2, 4, and then 10. We try to arrange them in the ascending order, the lambda. Okay, so these are the eigenvalues for the number 8a. So now we move on. 8b, they want you to use a characteristic equation to show this relationship, and the PQR are the integers to be determined. So what we can do is that we straight away apply something called the CAIE-Hamilton theorem. Let's apply CAIE-Hamilton theorem. Then from the characteristic equations, all the lambda, you can make it become a. So a cubed minus 12a squared plus the 12a plus the 8di, it will be equal to a 0 matrix. Then the a cubed will be equals to the 12a squared minus the 12a minus the 8di. That will be my first equations. Take the first equations multiplied by a, you will get a to the power 4 equal to the 12a cubed minus a 12a squared minus a 8a. That will be my second equations. You can see that the expression that you have are no a cube. No a cube, that means you just need to replace 1 into 2. You will get a power 4 is equal to the 12a cube. This one is a 12a square minus a 12a minus the 80i minus a 12a square minus the 80a. Expand, simplify, you get 144a square minus a 144a minus the 960i minus a 12a square minus the 80a. Simplify further, you get this one as the 132a square and minus the minus the 224 and then minus the 960i. Yeah, okay. So therefore, you have found the P, you have found the Q, and you have found the R. That's all. So the PQR found. Okay, so now we move on to the part C. So for part C, we need to find the matrix P and the diagonal matrix D so that it will fulfill this condition. So to find P, we need to find the eigenvector. So we'll just say that when the lambda 1 is equal to 2, let's say I choose lambda 1 is a negative 2. We have 3 lambda, right? 1 is a negative. So the first lambda is a negative 2. So you just need to replace negative 2 inside. Just need to replace negative 2 inside here, here, and here. And you go and choose 2 non-parallel vector to find the cross product. Okay, so I will choose the second and the third. So I will just need to do the cross product I, J, K over here. It will be 099 and 419. So if you do the cross product, you will get 72i plus the 36j minus the 36k. The multiple is 36. You can factorize the 36 out. So therefore, you can have the first eigenvector is 2, 1, negative 1. Then when lambda 2 is 4, same thing happen. We just replace the lambda inside the inside, and then we go and select 2 non-parallel vector. So over here, I just direct do it. You get 0i plus the 54j minus the 18k. So you will factorize the 18 out. You will get this one as a 0, 3, negative 1. So therefore, your second eigenvector will be 0, 3, negative 1. Now we want to go for the third eigenvector. Lambda 3 is equal to 10. So repeat the same process again. So I will choose this negative 12, 0, 0, 0, negative 3, 9. Do the cross product. I have a 0i plus 108j, then plus the 36k. I can take the 36 out, 0, and then 0, and then 3, 1. So therefore, my third eigenvector will be 0, 3, 1. So from here, therefore, I have found the P is equal to the E1. E1 just now was 2, 1, negative 1. E2 and E3. That is my P. And as for the diagonal matrix D, and as for the diagonal matrix D, because it's A minus 3i power 4, so it will be, this one it will be the lambda 1. This one is referred as a lambda 1, right? This one is referred as a lambda 2. This one is referred as a lambda 3. So the lambda 1 is negative 2 minus the 3 power 4. Okay. The diagonal matrix, all this will be 0. Then the lambda 2 is a 4 minus a 3 power 4. And the lambda 3 will be 10 minus 3 power 4. So if you just use your calculator, express it, you will get this one as a 625. This one is a 1. And this one will be 2401. And the rest are 0. That will be your matrix D. So, and done. That will be the answer for the question number 8C. And this will be the last question for this paper. So I will stop the video here. I'll see you next time. Bye-bye.